The question asks, oh, which one of the following is in a reduced echelon form? So remember the properties of row reduced echelon form matrices. First of all, if there is a zero row or column, it should go down in the bottom of the matrix. Every non-zero row must start by the leading one. I mean, the first non-zero entry of any non-zero row must be one. That's called the leading one. And then every other entry in the columns of a leading one must be zero. And then leading ones must follow the step-like pattern. Here, let's start. So every column starts with lead, every row, non-zero row, starts with one. Well, starts, I mean, after having some zeros, the first non-zero entry must be one. These are these are having step-like pattern. But what you have to notice is that everything else in the column of leading ones must be zero. So this guy must be zero. These guys are must be zero. So that's why this is not a row reduced echelon form. The second one we look at, well, okay, so the zero row goes down there. Every row which is non-zero, the first non-zero entry of that is one. It is following the pattern. But again, the column of leading ones must have all zero. Okay, that's why the second one is not. The third one, yes, so we have again the pattern starting with one, but then again, we don't have zero in the columns of leading ones. For the D, okay, so this starts with the leading one, and yes, it has the pattern. You don't need to have same kind of length steps. It can be just any kind of step you like. This is leading one, this is leading one, all the zero rows are down, and then everything else in the columns of leading ones are zero. Well, that means that we have a row reduced echelon form in part.